Good morning, students. So I hope all of you are able to view the screen properly.
Yes.
Okay, great. So as I was saying that we'll be discussing, the assignment questions what I gave in the last class, and we'll discuss one by one. So if you look into the first question, you know that if you look into the pattern, that a1 is equal to 0, a2 is equal to mod of a2 is equal to mod of a2 plus 1, mod of a3 is equal to mod of a2 plus 1, mod of a2 is equal to mod of a1 plus 1, mod of a3 is equal to mod of a2 plus 1, and in that way it proceeds. Note that the arithmetic mean means what? Of these numbers a1, a2, a3 up to an, that means a1 plus a2 plus a3 dot 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 up to an by n. Correct, no? Cannot be less than minus 1 by 2. Correct? That is what we need to prove. Correct, no?
Yeah.
Okay, let's see. The point is that the moment it is arithmetic mean and cannot be greater than 2, a minus 1 by 2, I'm sorry, cannot be greater than minus 1 by 2. The moment all these things, is mentioned in the question, one thing should, we should always be think is that how can we give, how I can keep it, this entire thing in terms of a1 plus a2 plus a3 up to an. Okay. So, and mod is given. Okay. As mod is given, how we can leverage that mod concept as well. Okay. So these are the things we are going to apply to solve this particular question. And as I said yesterday, dear students, that you will find that not a single concepts I'm bringing in here new. All I'm doing here is that how I can apply this thing, my existing knowledge, and why I'm giving all these statements. I could have just solved it so that you can find that pattern while solving similar problems. So what is given? It is given that a1 is equal to 0. So the moment we get a1 equal to 0, so from here what we can say is that a1 square is also equal to 0.
Yeah.
Now mod of a2 is equal to mod of a1 plus 1. Now if I need to get rid of mod, then what I can do is that I can make the squares of both sides of the mod, and then we'll get what? a1 square plus 2 into a1 plus 1. Correct or not?
Yeah.
Similarly, we can get a3 square is equal to a2 square plus 2 into a2 plus 1. In that way, it can continue till what? It can continue till an. In that way, it can continue till an. So that an square I can write is that an minus 1 square. Correct, na? Plus 2 into a into n minus 1 plus 1.
Yeah.
Now, dear student, if you look into the right hand side, I have 2a1, 2a2, 2a3, 2an minus 1. Correct, now?
Yeah.
So that gives a kind of indication that I need to add all these things, because that is the only way I can go to the arithmetic mean as it is given in the question.
Yes.
But it is still a n minus 1. So it is better to introduce another term called a n plus 1. Correct, na? So if we do one thing, a n plus 1 whole square, plus 1 is here is a subscript. So that will be what? That will be equal to a n square plus 2 into a n plus 1. Correct, not dear students?
Yeah.
Now what I'm going to do is that I'm going to add all these terms. If I want to add all these terms, okay, then what I'm going to get? In the left hand side I'm going to get is that a1 square plus a2 square plus a3 square up to an square plus an minus 1 square. Correct or not? a1 square plus a2 square plus a3 square plus dot 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 up to an square plus an plus 1 square. Correct or not, dear students?
Yes.
So that is equal to what? Let me write it properly. N plus 1 square. N plus 1 is a subscript, by the way. That is equal to what? In the right hand side, what we are going to get, dear students, is that a1 square plus a2 square plus a3 square plus dot 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 up to an square.
Yeah.
Correct, no?
Yes.
Plus what we are going to get? Plus 2 into a1 plus a2 up to an.
Yeah.
Correct or not?
Yeah.
Plus 2 into what we can write is that a1 plus a2 dot 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 up to an plus a3. I can write another term dot 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 up to an. Plus, if you see there is 1, it is added n times 1 plus 1 plus 1 up to n plus 1. No?
Yes.
a1 is added from a2's term till an plus 1's term. That is total n. No? So plus n. Now, if you see, dear students, is that in the left hand side, what you get? a1 square up to n square, and right hand side a1 square up to n square got cancelled. Na? Correct?
Yeah. Yeah.
a1 square plus a2 square plus a3 square up to n square in the left hand side get cancelled with a1 square plus a2 square plus a3 square up to n square in the right hand side.
Yes.
So then what we are going to get from here, what we are going to get, dear students, is that in the left hand side we get an plus 1 square. Correct? That is equal to right hand side we are going to get 2 into a1 plus a2 plus a3 up to dot 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 up to an
Yeah.
plus n. Na?
Yes.
Now tell me one thing, dear students. An plus 1 square can be negative. No,
Not coming.
it can't be negative. Correct? Na?
Yeah.
Because if an plus 1 is negative, then negative square is positive.
Yeah.
When an plus 1 is positive, then positive square to positive.
Yeah.
So from here, what we can conclude? We can conclude that 2 into a1 plus a2 plus a3 plus dot 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 plus an plus n is greater than equal to 0. It can be equal to 0. An plus 1 can be 0 in some case, right?
Yeah.
It can be at most equal to 0, but otherwise it will be always greater than equal to 0 if n plus 1 whole square. Correct, na, dear students?
Yes.
So we are almost there. So from here, what we are going to do is that we are going to now n, the number n is always positive. Correct, na? Because n is the number of terms, it cannot be negative.
Yes.
So what we are going to do is that 2 into a1 plus a2 plus a3 plus dot 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 up to an is greater than equal to minus n. Correct, now, dear students? Now we know one thing. If we divide both sides of an inequality by an positive number, inequality sign never changes. Correct, na? We discussed it in one of our previous classes. If we divide both sides of an inequality by a positive number, sign of inequality remains same. And that is true with multiplication also. So what we are going to do is that we are dividing by n. Then what we are going to get? 2 into a1 plus a2 plus a3 plus dot 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 up to an divided by n, okay, is greater than equal to minus 1. In as a reason justification, you can write as n is greater than 0. Now 2 is obviously greater than 0, so we can divide by 2 also. Sign of inequalities remain, it will not change, correct?
Yes.
So what we are going to get? A1 plus A2 plus A3 plus dot 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 up to an divided by n is greater than equal to minus 1 by 2. And that is what we wanted to prove, na, dear students.
Yes.
You know, what was the main crux of the problem? See, solution, you can look into the solution in book also, na. You can get this problem in book and you can find the solution also. Point is not that. Point is that how I can approach this problem. That is not written in book. What is the logic actually applied that I made square of everything? The only justification that why I made square. You can also ask me, sir, why you made square? A1 square, A2 square, A3 square, why you did so? Because I actually foresee just by making square only I can bring A1, A2, A3. And by making square, I can get rid of the mod. And then you can have another question that though I already answered, that why you introduce that an plus 1 again, not again, extra. So the question is that unless I bring this thing, I cannot bring that an in the right hand side. You see, dear students, here I marked in blue color.
Yes.
So these are the things should be, running in your mind whenever you get this kind of question. So if everyone is very comfortable with this solution, I can proceed to the next one. Or if someone is having any question, any smallest doubt, please feel free to ask me. Dear Sagnik, it is absolutely clear. Disha,
Yes.
okay. Disha, absolutely clear? Okay, great. Now let's proceed to the next question then. Okay, what do you think? Shall we proceed to the next question?
Yes. Yes.
Yes.
Hello? Okay. Next question is that if AIs
Yes.
are the positive real number, that question, no? Okay. So let me go to the next page and let me put, first pull the question first. If AIs are all the positive real numbers, then prove that 1 plus A1 plus A1 square into 1 plus A2 plus A2 square into 1 plus AN plus AN square is greater than equal to 3 power n into A1 into A2 up to AN. Interesting question. One thing is that, you know, uh, to proceed with this question, the first and foremost thing is that as we see the sign of inequality, where the product is also there A1, A2 up to AN, okay, and left hand side there are, I see the summation and then their product. Back of my mind, I can think of, yeah, can I apply that arithmetic mean is greater than equal to geometric mean? That should play first. Can I think of? Because thought process is the important before solving this kind of relatively complex questions. What is important is the thought process. Solution is a mere doing of our, application of all of our existing, knowledges. But how to apply those knowledges? Why we should apply that? That is very, very important. Okay. So that should first play in your mind that can I think of arithmetic mean is greater than equal to geometric mean first. Second thing should come is that let me look into that these three numbers 1 a1 a1 square. Okay. If we just purely look into these three numbers 1 comma a1 comma a1 square, what we can see? We can see one thing is that their arithmetic mean should be what? Their arithmetic mean is going to be 1 plus a1 plus a1 square divided by 3, correct, na, dear students? And what will be their geometric mean? Their geometric mean should be what? Can someone please tell me what will be their geometric mean? Divanshu, for say, or anyone, Mohor, Sagnik, Vijita, Disha.
Root of A1.
Root of what root?
Cube root.
Cube root. Very good. Cube root of 1 a1 and a1 square. That means 1 into a1 into a1 square
Cube root.
power 1 by 3. Correct? Na? Cube root means 1 by 3. Na? And that becomes what? a1 power 3 power 1 by 3.
Yeah.
That is nothing but a1. Correct or not? All of you agree to me? Disha? Divanshu?
Yes, sir.
Okay. So, what do we know? That arithmetic mean is greater than equal to geometric mean? So, arithmetic mean is greater than equal to geometric mean. That actually help us to conclude that 1 plus a1 plus a1 square divided by 3 is greater than equal to a1. That implies what? That implies, I can write in the next line, that implies 1 plus a1 plus a1 square is greater than equal to 3 into a1. Correct or not, dear students?
Yes.
Now, similarly, what we can get? Similarly, we will get 1 plus a2 plus a2 square is greater than equal to 3 into a2. 1 plus a3 plus a3 square should be 3 into a3. In that way, I can go up to nth term, na, dear students. 1 plus an plus an square is greater than equal to 3 into an. All of you are absolutely clear?
Yes.
Now what I'm going to do is that I'm going to just, product of both the left hand side of the inequalities of all these terms and the right hand side of the inequalities of this term. Got my point, no, dear students? So what I'm going to do now, as I just said, I'm just going to multiply all these things. Then what we are going to get in the left hand side? 1 plus a1 plus a1 square, correct, na? Into 1 plus a2 plus a2 square. In that way, it will continue till 1 plus an plus an square, correct, no? That should be greater than equal to how many 3 are multiplied?
N.
In number, so 3 power n into a1 into a2 into a3 up to n, and that's what we wanted to achieve, no? When you looked into the problem for the first time, you found it is difficult. It is indeed difficult. Difficult is a word which is relative, right? Lot of things could be very easy for you, but for me it is difficult. Possible, right? As a teacher also, it could be something that it is difficult for me than you. In not on some topic, something, okay, maybe. Definitely possible, not maybe. But what I'm saying is that the approach, what should come to your mind, that's what is very, very important to actually understand. Srijita, is it absolutely clear to you? Okay. I didn't hear.
Yes,
Okay.
sir.
Great. Thank you very much for your reply. Okay. If absolutely clear, so this question, then I can proceed to the next one. Shall I? Or if you have any doubt here.
No, it's
Okay.
fine.
So our next question was this, no? That if P is the first term of in arithmetic means, correct, no?
Yes.
So let's discuss on that question now. See, those who are actually able to crack this problem, it is not that they actually cracked it from the day one. It is almost impossible, I can say. But with practice, extensive practice, okay, will definitely lead you to this one. And that is why I always suggest strongly, you are doing DPPs very good. DPPs are, you now you understand the complexity of the DPPs are much lesser than this, no?
Mm.
Okay, so and this kind of questions, as I said in the other day, that will never come to your board examination, but definitely important for your entrance examinations. Board examinations, DPP is fine. Now, this kind of problem, how you can solve, as I just answered and just repeat, is that through practice. That's it, nothing else. And for practice, the right platform is a right practice test there in the www.konarclasses.com. As simple as that. Okay. Now, let's approach this problem here. So, what is the question here? Uh, the statement is something like that is very important to understand. If P is the first of the n arithmetic means between two unequal positive numbers, and Q the first of n harmonic means between the same two numbers, so that Q cannot lie between P and n plus 1 by n minus 1 complete whole square, okay, into P. Now, how to do this thing? So, if you recall, when we discussed, earlier when we discussed about arithmetic means and geometric means and harmonic means, is that we see what A and B. Let me take these two numbers, unequal positive numbers. Now, let's take A and B are such two unequal positive numbers. And how many arithmetic means we are inserting between them? According to the question, is that n arithmetic means we are inserting between them. No? So that
Yes.
means A1, A2, A3, up to you get AN and then B, correct? No? So now
Yes.
how many terms are there? There are total n plus 2 terms, and these n plus 2 terms are in arithmetic progression, correct or not?
Yes. Yes.
Absolutely clear. So
Yes.
now let's assume D be the common difference of this AP. So this is an AP, right? No? Dear students,
Yeah.
this is in AP. This is in AP. Let be the common difference. Let D be the common difference of this AP. Then what we are going to get, dear students? We are going to get that B is equal to, B is what? N plus 2th term, na?
Yeah.
B is equal to A plus N plus 2 minus 1, that is N plus 1
Yeah.
into D. By this time you will be knowing this thing, na, dear students?
Yes.
So from here what we are going to get? We are going to get D is equal to B minus A by N plus 1. Clear or not clear?
Yes.
I will explain that why I am doing all this stuff. Then what is P? P is the first of this arithmetic mean. That means, can you tell me what is P? P is nothing but A1, capital A1.
Yeah.
Correct or not, dear students? P is
Yes.
nothing but capital A1.
Yes.
What is capital A1? Capital A1 is nothing but A plus D. Second term of this arithmetic progression under consideration. Correct or not? So that is equal to what? A plus B minus A divided by n plus 1. Correct or not, dear students?
Yes.
If we simplify further, what we are going to get, or I can write in the next line itself. So from here, what we can get is that P is equal to n into A plus B by n plus 1. N into A plus B divided by n plus 1. Correct, no?
Yes.
So this we get P. Now, why you are interested to find the value of P? Because in one of the result, what is C, show that the Q cannot lie between P and n plus 1 by n minus 1 whole square into P. Na?
Yes.
And that is why I found the value of P in terms of the known things. What are the known things? A and B are known things. Two unequal positive numbers, and n is the n arithmetic mean positive number. N is also known to me. This is one thing I got. Correct, na, dear students?
Yes.
Now, let's now look into the harmonic mean part of that according to the statement. So let me give this as equation 1. Now, what about the harmonic mean? So let me use a different color so that we can later we can make it in, you can always differentiate. So it is the same positive two positive numbers A and B. Then we are inserting harmonic means. How many harmonic means are there? In harmonic means we are inserting, suppose H1, H2, H3. Correct, no, dear students?
Yes.
In that way, up to Hn B. Now, if you look into this sequence, this implies that 1 by A, these are in harmonic progression. Na? So let me write this thing. This is in HP, correct? This is in harmonic progression. As this is in harmonic progression, as I suggested in the yesterday's class, that whenever you see the some numbers in harmonic progression, to make things simpler, is that let's take the reciprocal and consider that those reciprocal numbers are in arithmetic progression. That implies what? That implies 1 by A, comma 1 by H1, comma 1 by H2, comma in that way 1 by Hn, comma B are in arithmetic progression. Correct or not, dear students?
Yes.
Now, we need to find, as this is in arithmetic progression, let's consider that D dash be the common difference of this AP. Let D dash, D prime be the common difference of this AP. Correct, no, dear students? As D be the common difference of this AP, so what we are going to get it from here? So what we are going to get it is that 1 by B. So from here, what are we going to get? 1 by B is nothing but n plus 2th term of this arithmetic progression. Now 1 by A, 1 by H1, 1 by H2 like this.
Yes.
So that should be 1 by A plus n plus 2 minus 1, that is n plus 1 into D dash. Correct? So from here we can find the value of D dash. From here you can find the value of D dash is equal to, okay, I can simplify a little bit. So this implies what we are going to get, you know, dear students. 1 by B is equal to, sorry, D dash equal to, from here we can get D dash equal to 1 by b minus 1 by a into 1 by n plus 1.
Yeah.
Correct now? 1 by b minus 1 by a into 1 by n plus 1. So that is equal to a minus b by n plus 1 into ab. That implies d dash is equal to a minus b divided by n plus 1 into ab. So now let's focus on q, because that is also our very important thing. So what we can say, 1 by q is equal to what? Can you tell me? 1 by q is equal to what? 1 by h1, na? Correct or not? Because q is the first harmonic mean
Yes.
among these n harmonic means inserted between a and b. So what we can say, 1 by q is equal to 1 by h1, because q is equal to h1, 1 by q equal to, hence 1 by q equal to 1 by h1. That is equal to 1 by a plus d dash, na?
1 by a plus d. Yes.
Because 1 by h1 is the first term of the second term of the arithmetic progression, 1 by a1, comma 1 by h1, comma 1 by h2, up to 1 by hn, comma b. Correct, na, dear students? So what we get? 1 by q is equal to 1 by a plus t dash. So let's find the value of q from here. So we just found the value of d dash, that is equal to what? The value of d dash we get is that a minus b divided by n plus 1 into ab. Correct or not?
Yes.
So from here what we get is that this implies, 1 by q is equal to n into b plus a n into b plus a divided by n plus 1 into ab. Do you agree to me?
Yes.
Correct or not? We are going to get out of here. So from here what we get is that q is equal to n plus 1 into ab, n plus 1 into a into b divided by nb plus a. Correct or not? That we can give as equation number 2. Clear or not clear? Now,
Yes.
what we need to show? Now, these are the values of P and Q we have achieved so far. But what we are supposed to show? We are supposed to show that Q cannot lie between P and this expression n plus 1 by n minus 1 whole square into P. Now, what is n? N is a number which is greater than 1. Correct or not? N is a number which is greater than 1.
Yes.
So from here, what we are going to get, let me use a different color. So as n is greater than 1, this implies n plus 1 definitely greater than n minus 1. No doubt should be. So that implies what? That implies n plus 1 by n minus 1 whole square, n plus 1 by n minus 1 whole square should be greater than 1, no? Correct or not?
Yes.
Obviously. And if I multiply it by p, that should be greater than p.
Yes.
Correct or not?
Yes.
Hmm?
Yes.
Because why? Because p is a positive number. P has to be positive. And why p is positive? Because a and b are positive numbers. So if the two extreme ends numbers are positive, then all the arithmetic means in between them has to be positive. Correct?
Yes. Yes.
So then what we are going to get is that n plus 1 by n minus 1 whole square into p is greater than p. That we have achieved one thing. Correct?
Yeah.
So this is one thing what we achieved. So let's mark it. Let's, you know, like this. Now we need to find a relationship between p and q. What is our target? Again, go back. We need to show that q cannot lie between p and n plus 1 by n minus 1 whole square into p. Okay, one thing we have partially achieved, right or not?
Yeah.
Now all you need to show is that p is greater than q. Correct or not?
Yeah.
We are able to show that p is greater than q. That means what? Okay, then we can say is that q is less than p. Already we have just achieved p is less than this thing n plus 1 by n minus 1 whole square into p. So we'll able to establish. Are you getting my point? That why we need to show the relationship between the inequality relationship between p and q. As
Yes.
we need to show this thing, so what we are going to do? Let's do p by q. Correct? So let's do p by q. If we find the value of p by q, so what is the value of from equation 1 and 2? If you just look into equation 1 and 2, that p by q, how we can get the value of p by q? P is equal to, from equation 1, we get p is equal to na plus b by n plus 1.
Yeah.
Okay, so let me write it down. So what is that? It is na plus b by n plus 1 into nb plus a, correct, na? nb plus a divided by n plus 1 into ab. Now, dear students, as you see that in the right hand side, whatever we have, it is all actually known to us. A is known to us, B is known to us, N is known to us. Now, let's see. So then let's explore whether we can get some relationship, some inequality relationship between them or not. So to do this thing, what we are going to get, let's simplify the right hand side. If we simplify the right hand side, what we are going to get, the denominator is, you are going to get is that n plus 1 whole square into a, n plus 1 whole square into ab, and then na plus b into nb plus a. So that should be n square into ab plus ab plus n into b square plus n into a square.
Yeah.
Correct?
Yes.
So now what is our target? Our target is to show the relationship between p and q. That means whether p is greater than q or p is less than q. And to achieve that, the best and best way to do this thing is that let's find the value of the expression p by q minus 1. Correct, now, dear students? So that's equal to what? N square ab plus ab plus n into b square plus n into a square divided by, just a minute, n plus 1 whole square into ab minus 1.
Yeah.
And what is the justification I gave? I gave the justification because this will help us to find the relationship. So now if we simplify this thing, so what we are going to get? This is, denominator, we get the same thing. What we get, n plus 1 whole square into ab. So here what we get, n square ab plus AB plus n into b square plus n into a square minus n plus 1 whole square is what? N square plus 2n plus 1. So n square AB, correct or not?
Yes.
Minus 2n AB, correct or not?
Yes.
Minus 2n AB, correct or not?
Yeah.
And plus AB. Minus AB actually, sorry. Minus into plus AB, correct?
Mm.
So if we do this thing, then n square AB got cancelled. AB and minus AB got cancelled. And then what we will end up with is that n
Yes.
square plus n square minus 2nab.
That's NBS.
Correct, no? So from
Yes.
here what we get, p by q minus 1 is equal to, if we take n common, we get a square plus b square
Nine.
minus 2ab
Mm.
divided by n plus 1 whole square into ab. Now here it is little to be happy about, because we something, whenever we get a square plus b square minus 2ab, we know that, oh, okay, we are going to get something.
Mm.
It is coming to our formula.
Mm.
So now what we are going to do, but ab is there in the bottom, correct or not? ab is there in bottom now.
Mm.
So n is positive, correct or not? So
Yes.
n plus 1 is also positive. So this, all these things, what we are getting is that this implies p by q minus 1 is equal to n by n plus 1 whole square into ab into a minus b whole square, correct or not, dear students?
Mm.
Now all the terms in the right hand side is positive. N is positive, n plus 1 whole square is positive, a into b is positive because a and b are distinct positive numbers. A
Yeah.
minus b is also positive, correct or not? Whole square, correct? A minus b whole square is positive. So what we see is that p by q minus 1 is greater than 0.
Yes.
So from here, what we can conclude is that p by q minus 1 is greater than 0.
Mm.
So now this implies p is greater than q. We cannot write always. Since p is positive and q is also positive, then only we can write this thing.
Yes.
If you multiply both sides of the inequality by a positive quantity, sign of inequality doesn't change. So what we get? We get p is greater than q, correct or not? So from
Yes.
here, what we get is that q is less than p,
Mm.
and already we have achieved this thing now, that p is less than what? N plus 1 whole square by n minus 1 whole square, n plus 1 by n minus 1 whole square into p,
Yes.
correct or not?
Yeah.
That means what? That establishes our, the statement, no? What has been given in the question, that q cannot lie between p and n plus 1 by n minus whole square into p,
Yeah.
correct or
Yes.
not?
Yeah.
This proves that, this implies q cannot lie between p and n plus 1 divided by n minus 1 whole square into p. Clear or not clear? Absolutely clear, dear students.
Yes.
So after the class, once I send you the notes, again you need to go through it once, okay, so that you can understand each and every point, and most importantly, how to apply those points in your in a prospective problem. Okay.
Yes.
So now let's go to the next problem. Find the sum. Correct, no?
Mm.
That 1 into 2 into 3 into 4 into 5 plus 2 into 3 into 4 into 5 into 6. Anyone is able to do this question? Sagnik, able to do?
Yes,
Divansu?
I do.
Huh?
Oh, sir.
No, Divansu, you already said. I understood. Sagnik?
No, sir. I did.
Okay. No one. Okay. Let's work on it. Again, see, it is quite possible that at this level you are not able to answer it. But, you know, once we discuss this thing, then you'll find, yes, sir, I can now do this kind of problem with comfortability. And that is the purpose of these classes. See, when I was also a student like you, I was not also able to do this thing. So it is not that everyone knows on the day one. It is not like that. What is important is that, as I said, that learning process. That is very important. So this is question number 4, as I gave. Let's spend the next 5 minutes, and you'll like it. You'll find, yeah, this is the way to solve. So, dear students, if you look into it, what is the sum here? In very simple terms, if we find the in the sum, is that we need to find the sum something like this. So the given sum, this is equal to what we can write, dear students, is that if you remember the symbolic representation of r into r plus 1 into r plus 2 into r plus 3 into r plus 4, where r is varying from 1 to n minus 4. First, you feel comfortable that you understood this symbolic representation or this summation or not.
Yeah.
If someone is not able to understand, never hesitate. If you hesitate today without understanding, not asking me, then you need to repel later that, oh, I should miss that time. Don't do this thing. And not with me, with anyone, with any teacher. Unless you are completely clear, it is your responsibility to ask the teacher and get it clarified. Think from a teacher's perspective. A teacher needs to handle so many students, right? So now the point is that once you fully understood this thing, I'm just going to work on this thing, because in simple term it is very difficult to perform that sum, because here it is r power 5. If you multiply all these things now,
Mm-hmm.
it is a polynomial of degree 5 in r.
Yes.
But if you think about our natural number, addition, we know the sum up to the first in natural numbers, sum up to the squares of the first in natural number, sum up to the sum of the cube of the first in natural numbers, and sum of the fourth power of the first is natural number. But here it is 5.
Mm-hmm.
How to proceed? So that route is actually closed in front of us. So then we need to rethink that how can we do something, we need to play with the numbers. So what I'm going to do, dear students, is that I just want to focus. Let me use a different color. I just want to focus on this expression and want to find a pattern whether I can rewrite this thing as a addition or subtraction of two individual patterns of the similar type. So what I'm going to do, dear students, so this expression, if I look into it, is that, let me write whatever is there, r into r plus 1 into r plus 2. Okay, let me do one thing. Let me write it here so that it will be a big expression. So let me write it here. So that I'm going to write is that, because I know I need to divide by something, whatever I'm going to write. is that r into r plus 1 into r plus 2 into r plus 3 into r plus 4, and I am just introducing one more term is r plus 5. Okay, got it, no? Then what
Yes.
will happen? What I'm going to do is that minus, I am doing r minus 1 into r plus 1 into r plus 2 into r plus 3 into r plus 4. Just to concentrate on the numerator. You can take r into r plus 1 into r plus 2 into r plus 3 into r plus 4 common. Then in the first one you will get r plus 5 minus of r minus 1, that is minus r plus 1. That means you are introducing 6 in the numerator, so I should divide by 6. But why I did so? I did so just to make this, but if you look into the two expressions in the numerator, they are in pattern. What kind of pattern they are in? If we notice, if we considered that, you know, the first one is the rth term VR. Suppose let's write this as VR. Then the next one will be VR minus 1. Tell me, do you agree to me?
Yes.
Correct, no? Just to replace r by r minus 1, you get the second expression. So then, dear students, what we achieved? We achieved something like this. So from here, what we are going to get is that this is nothing but VR minus VR minus 1 divided by 6. Correct or not? Where r is varying from 1 to n minus 4. Now let's focus on this. Once we get this thing, we don't need to worry that much, because that we are going to write is that 1 by 6. Put r equal to 1, what you will get? V1 minus V0, correct?
Yeah.
Then you put r equal to 2, you will get what? V2 minus V1. Then you put r equal to 3, then what you will get? V3 minus V2, correct, na?
Yeah.
In that way, if you continue, what you will get? The n minus 5th term, Vn minus 5 minus Vn minus 6, correct, na? N minus 5, then n minus 4, correct, na? So what will be Vn minus 4 minus Vn minus 5, correct or not? So if you see that V1 get cancelled with this V1, V2 is cancelled with, I'm so sorry, V1 is cancelled with this V1, V2 is cancelled with this V2, this V3 will get cancelled with some other terms, na? I'm not saying the next term. Similarly, you'll find that Vn minus 5 is cancelled with this. Similarly, Vn minus 6 will get cancelled with the someone in the previous term, correct? Ultimately, what we'll end up with? We'll end up with 1 by 6 into Vn minus 4 minus V0. Correct, not dear students? Now, what is Vn minus 4? Just VR. Instead of VR is what? VR is R into R plus 1. So let me write it down. What is VR? Where VR is equal to R into R plus 1 into R plus 2 into R plus 3 into R plus 4 into R plus 5. Correct, no? So now all you need to do is that to find Vn minus 4, We need to just replace r by n minus 4, correct or not, dear students? Then what we are going to get? We are going to get 1 by 6 into, if we apply this thing, so what we are going to get is that n minus 4 into n minus 3, correct or not? By the way, v0 to 0, because r equal to 0, you'll get 0, correct now? So actually, it is actually becoming 1 by 6 into vn minus 4. N minus 4 into n minus 3 into n minus 2, correct? Into n minus 1 into n plus 1, and that is the required sum. So without touching any formula related to the arithmetic progression and all these things, we are able to achieve it now, dear students. So no need to worry. Again, you may think, okay, why I was not able to do. It is quite common, dear students, today. But as time goes by, I will give you many more problems like that in all the previous topics also. Differential calculus, integral calculus, sequence series, and all these things, whatever you will do. Your task is to complete this thing on time and get back to me. That will be your task. If you do not solve this problem as I am suggesting, then what will happen? We'll lag behind. I'm just telling you the consequences. Okay. As Mahatma Gandhi said, our future depends on what we do today. So we need to think that what we are doing today, if we are putting our effort to do this thing, eventually our future will be bright. Eventually, it is impossible that we are putting our effort consistently and end result is not coming as a great one. It is impossible. History never showed that thing, and history repeats itself. If you study social science, you can get it. Anyway, so what was the fifth question, dear students?
So the minimum non-negative values.
Exactly. Find the minimum non-negative values of A, B, and C, given that the equation x power 4 plus ax cube plus bx square plus cx plus 1 equal to 0 has only real roots. Okay, so how to approach this problem, dear students, is that this problem we can will be more understandable if we can approach the concept of the theory of equation. Okay, if you look into this equation, let's name this. Let me put the question first, dear students. All of you have another 10 to 15 minutes now, dear students.
Yes.
Yeah, please, I request you to please spend another 10 to 15 minutes so that we can complete this. And
Yes.
tomorrow we'll discuss with infinite series. Okay.
So I was trying the trial and error method in this question.
But point, I appreciate there is nothing wrong. Whatever the method you do, it is always you are doing some kind of a experiment. That is nothing wrong. But the point is that with trial and error method, what will happen is that it is a time consuming process. Dear students, our exam pattern is like that we cannot afford much time, right? Not only that, we need to we need to answer on time. Time is a very important parameter, not only for examination, for our preparation also. Today, if you do not make use of time properly, it is going to be difficult. Anyway, let's approach this solution to this problem. Let's consider fx equal to this polynomial expression, that equation what has been given. Okay. So what is fx here? Fx equal to x power 4 plus a into x cube plus b into x square plus c into x plus 1. That is fx. Let's fx is. Now, what is given, that condition is very important. What is given in the condition? The condition given is that ABC are non-negative. Now, as ABC are non-negative, no equation of these roots can be positive. Okay, got my point? Why? That we'll discuss in details about, while we'll discuss about the theory of equation. Okay, so that actually comes from a rule of this thing. So as this thing, and in context to that, today, if you are able to solve this question is okay. I repeat, as A, B, and C are non-negative, no roots of the equation fx equal to 0 can be positive. Now further, f0 is not equal to 0. Correct, no? How come f0 is not equal to 0? Because f0 is equal to 1, no? How can it be 0?
Yes.
Okay?
Yes.
All the roots of the equation are negative. So, two things. As ABC are positive, that is non-negative, as ABC are non-negative, no roots of the equation fx equal to 0 can be positive. So, let me write it down. As A, B, C are non-negative, A, B, C are non-negative, what we can conclude? We can conclude that no roots of the equation fx equal to 0 be positive. No roots of the equation fx equal to 0 be positive. And again, further we see, sorry, what is the value of f0? F0 is equal to 1, na? If you apply 0 in the right hand side, that is not equal to 0. That means what? 0 is also not a root of the equation fx equal to 0. Correct or not? So with these two statements, what you can say is that this implies that all the roots of the equation fx equal to 0 are negative. Okay? All the roots of fx equal to 0 are negative. Now let's assume those roots are, x1, x2, x3, x4. Correct? Let the roots be x1, x2, x3, and x4. So what we need to show? Find the minimum non-negative values of ABC so that the given equation has real roots. Now, we know from the relationship between the roots and coefficient what we can write. Summation of xi is equal to minus b by a, means that, sorry, not minus b by a, coefficient minus of coefficient of x cube by coefficient of x power 4, that is equal to minus a, na?
Yeah.
Relationship between the roots and coefficient 1 to 4. Correct? Clear or not clear?
Yes.
And dear students, sometime without writing this thing, if I write that summation of x1 is equal to minus a, that means is that it is x1 plus x2 plus x3 plus x4. Huh? This is also one way of representing.
Yes.
Quick representation. And what we can write then? Sum of the products of this root 2 taken 2 at a time. That should be equal to b, if you remember the relationship between the roots and coefficient. And similarly, x1, x2, x3, that should be equal to minus c. Correct, no? And finally, x1 into x2 into x3 into x4, that should be equal to 1. Correct, no, dear students?
Yeah.
Now what we see is that x1, x2, x3, x4 all are negative. That means we what? Minus x1, minus x2, minus x3, minus x4 all are positive. Correct or not?
Yes.
Absolutely clear.
Yes.
So what we can say is that as minus x1, minus x2, minus x3, minus x4 are positive, what we can say, as all these numbers are positive, we know that arithmetic mean is greater than equal to geometric mean, dear students. Arithmetic mean is greater than equal to geometric mean. What is the arithmetic means of these numbers? Minus of x1 plus x2 plus x3 plus x4 by 4, correct now?
Yes.
Minus of x1 plus x2 plus x3 plus x4 divided by 4, correct now? This is greater than equal to geometric mean. Geometric means of minus x1 into minus x2 into minus x3 into minus x4 power 1 by 4.
Yeah.
That means actually it is x1, x2, x3, x4 power 1 by 4. Correct, no? This implies what? x1 plus x2 plus x3 plus x4 is what? Minus a. So minus of minus a by 4. That means a by 4. A by 4 is greater than equal to x1, x2, x3, x4 is 1. So a by 4 is greater than 1. So from here what we are going to get? A is greater than equal to 4. Correct, no, dear students?
Yes.
But we need to find which is the minimum. Look at the question. Find the minimum of the numbers ABC. Na? Correct or not? Clear or not clear?
Yes.
Now, how we can find the relationship between the, for an unequal relationship for the number B? For that, we are taking the numbers as x1, x2, x1, x3, x1, x4, x2, x3, x2, x4, and x3, x4. Okay, what are the numbers we are taking, dear students? We are taking as x1, x2, comma, x1, x3, comma, x1, x4, sorry, comma, x2, x3, comma, x2, x4, and x3, x4. All these numbers are positive. We are taking two at a time, na, dear students. You can apply permutation combination. So here also you can apply the concept of arithmetic mean is greater than equal to geometric mean. Recall, dear students, what I said yesterday, that always you will come back to this thing. Arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean in future. And future is immediately. Yesterday we discussed how important it is. Without that we cannot establish this one. And if you apply this thing, what we are going to get? What is the arithmetic mean you are going to get? Is that nothing but summation of x1, x2, correct or not? Divided by how many numbers are there? 1, 2, 1, 2, 3, 4, 5, 6. 6 is greater than equal to geometric mean. Again, what you will get? x1, x2, x1, x3, x1, x4, x2, x3, x2, x4, x3, x4. All these things will get x1, x2, x3, x4 whole square. Correct, na? Power 1 by 6. Correct, not? So ultimately you will get 1. Are you getting my point, dear students? Hello?
Yes.
So what is x1, x2? x1, x2 is nothing but b. So b is greater than equal to 6. Okay. Now, what we are going to do, dear students, now we are going to take 3 at a time. Now we are going to take 3 at a time. So what are the 3 numbers? As minus x1, x2, x3. Minus x1, x2, x3. See, x1 into x2 into x3 is negative because all are negative. x1 is negative, x2 is negative, x3 is negative.
Yes.
So their product has to be negative, but minus of x1, x2, x3 has to be positive. So minus x1, x2, x3, comma, minus x1, x2, x4, comma, minus x1, x3, x4, x1, x3, x4, and minus x2, x3, x4. Minus x2, x3, x4. Correct, no? Are positive. So from here, what we are going to get? So we, as positive, so here also we are going to apply this concept. Arithmetic mean is greater than equal to geometric mean. So what is the arithmetic mean here, dear students? Is that summation of x1, x2, x3, they are negation, no? Got it or not?
Yes.
So negation of their summation x1, x2, x3 divided by how many terms are there? 4 terms are there.
Yes.
That should be greater than equal to again minus x1, x2, x3, minus x1, x2, x4, minus x1, x3, x4, and minus x2, x3, x4. If you multiply, that become positive, and x1 square, x1 cube, x2 cube, x3 cube, x4 cube, that all become 1. That is greater than equal to 1. Correct or not? And we just see few minutes back the relationship between the roots and coefficient x1, x2, x3 is minus c. So ultimately it becomes c by 4, correct or not?
Yeah.
So that implies, c by 4 is greater than equal to 1. So that implies c is greater than equal to 4, no, dear students?
Yes.
So what we see is that a is greater than equal to 4, b is greater than equal to c, c is greater than equal to 4. Now let's go back to the question. Find the minimum non-negative values of a, b, c, that is 4. Given that the equation has only real roots. These are the questions for JEE advanced type of. And again, I repeat, dear students, a methodical plan, methodical preparation will achieve you this thing. With this note, I would like to conclude the class for today. Unless you have any specific question for me, for all the DPP questions, I already sent you the class notes, the guidelines. So whoever asked for it. If you still have any doubt, please be in touch with me over WhatsApp. Tomorrow at 9 o'clock, we'll be starting Infinite series. Okay, thank you. All right.